Hi, period 7 integrated 2. This is Mrs. Dinkelman, and this is me going over the notes for Tuesday, November 14th, since I am gone for a meeting. We're doing something really similar to yesterday, except for we're going back to the x squared graph to see if we can shift it kind of quickly rather than identifying a whole lot on there. One thing I will say is I changed the variable here when I typed this up, but I forgot to change this one. So we're still thinking about HK, which is the vertex, which can be helpful in doing these problems. So let's just quick remind ourselves what x squared looks like. If it's helpful, make a quick little table of values if you don't remember. So obviously if I plug in 0, 0 squared is 0. If I plug in a 1, 1 squared is 1. Remember, this is symmetric, so if you know one side, you know the other side. If I plug in a 2, I would get 4. And again, I'm going to make one on the other side. It's more important as we shift this around that you be a little bit more perfect because it's going to ask you some questions about the zeros and the y-intercepts and that kind of thing. So the domain for this one is all reals. Really similar to the absolute value because we have this going on where it's going to kind of go left and right forever and ever. And then instead of a V, it's just rounded, but we do have that vertex type thing here. So it's going to be y is greater than or equal to 0. This one doesn't have a transformation because it's called the parent function. So we're going to take this parabola, this bowl-looking thing, and move it around and stretch it and shrink it to find the other graphs. The axis of symmetry, again, is that thing that cuts it right in half. So that's technically x equals 0. The y-intercept where it crosses the y-axis is 0. And then the zeros are where it crosses the x-axis. Again, if you want to write x-intercept there as well, that's at 0 as well. That's where it's crossing the x. So all these transformations do the same thing, meaning if something's on the inside with the x, it's going to tell us to move left or right. If it's on the outside, it would tell us up or down. So this one is going to move us to the right 2. Remember, on the inside, it's kind of that poser. It changes what it says. So it says -2, but it's going to do the opposite, which is go over +2. So my new vertex is at 2. And then I can do these same points that I had here. What you might notice about a parabola is the first point kind of goes up 1 over 1. Then I can make a repeat. The second one goes up a little bit more than that. It really goes up 1, 2, 3 over 1. So if you want to kind of keep that same pattern, you can. And then repeat that over here, which is actually really nice. Did I do that right? 1, 2, 3. Again, I want to kind of be perfect on the axes since it's asking me those questions about the zeros. So domain is all reals. This did not change the range. It's still 0 is the very lowest it gets. The transformation we talked about before we did it, it's to the right 2. Now the axis of symmetry is over here at 2. The y-intercept is at 1, 2, 3, 4. Another way to check that would be to plug in the x is 0. So if I plug a 0 up here in for x, I should get +4. That's the other way to check if you don't want to do it by your graph. And where does it cross the x-axis? That's at 2. Okay, so this one, the +3 is on the outside, so that's going to move us up 3. And kind of the same as yesterday. If you feel like you know what you're doing and you want to stop listening to the video and you want to just go try it and check the solutions, feel free to do that. So I'm going to do that thing where the first point was up 1 over 1, and the second one I had to go up 1, 2, 3. That will change a little bit as the number in front of the x squared changes, so we'll talk about what to do there. Made that one a little bit white on that side. Domain, all reals. This one changed the range a little bit, so it is 3 and greater, so y is greater than or equal to 3. The axis of symmetry is still at 0. The y-intercept is 3. And the 0 is kind of a trick question. This is none. This would actually be if we tried to solve this where we would get imaginary numbers, because not all parabolas cross through the x-axis. Okay, on this one, the 3 in front is going to make it skinnier. Again, I think they call that a stretch, which is fine. Just let's talk about this one down here. The 1/2 makes it wider, but it also is a -1/2, so it's going to turn it so that it opens downward or is upside down. So we'll talk about how we do that as we go through here. So this one's just skinnier, which means my vertex is still at 0, 0. This time, instead of going up 1 over 1, I'm going to go up 3. 1, 2, 3 over 1. And the other one, I actually don't, like, in my brain have what I should do next. We could plug in a number. So if I plugged in a 2, so let's think about that. Plug in a 2. Remember to do exponent first. So we would get 12, which is kind of off here. But I kind of feel like once I have that one, I know it's just really super skinny. Domain is all reals. Range still just greater than or equal to 0. Axis of symmetry is 0, crosses the y-axis at 0, and actually crosses the x-axis at 0 as well. Okay, I'm going to answer a little bit here. So again, I talked about it being wider, but there's no other shift or anything there. So on this one, what I would do is I would go down 1 over 2 to make it wider. Again, I knew it was down because it was a subtract sign. And then, or not a subtract, but a negative sign. Put a symmetric point. And I'm just going to go with those few. That's going to help me make it wider. So again, from here I went down 1 over 2 to find how to make it wider. There's more questions to answer there, so I'm going to have you do that part. Let's go look at one that shifts a little bit more than that. So let's look at 7. So there's a couple things going on 7, and then I'll have you try on your own. So this transformation, there's a couple things going on. In here, it's going to move to the left 2. On the outside, it's going to be up 4. And then the negative in front is going to have it open down, or it's going to be upside down. Okay, so again, that vertex is at -2, 4. 1, 2, 3, 4. Now from here, I would go down 1 over 1. Now I want to be really careful how it's going to cross through the axis here so that I can be able to answer the question next. So I'm just going to do a little chart over here just to verify. We'll see what happens here. So I'm going to plug in x is 0 and see what happens. So if I plug in a 0, it's going to be negative of 2 squared plus 4. I do the squared first because that's on the inside. So 4, so negative 4 plus 4 is 0. So 0, 0. That's going to help me know at least where it crosses the x and y in one spot. Again, it's symmetric, so now I know this one is going to be over here as well. All right, let's answer. Domain, all reals. Range, well, let's see, that's up at 4, and then it's going to be less than or equal to that. Axis of symmetry is at -2. Y-intercept, so it's crossing this y-axis at 0. And then it has 2 x-intercepts. So one over here at, let's see, is that 1, 2, 3, 4, -4, and then also at 0. Okay. So go ahead and try to finish up. Don't forget you have the matching on the other side of that. And then if you didn't finish your absolute value worksheet, definitely finish that up. We do have a quiz on Friday on some of these transformations. So if you would like to hold on to that so that you have a study tool, you can. If you would prefer to turn it in, you're welcome to do that as well.